So in this video I want to look at applying integrals to volume. So one of the properties of integrals that you can use when you're looking at volume is if you've got a shape, now we've got a nice regular pyramid here, but if you've got some other shape which has got a regular cross-section or a cross-section that changes, you can actually integrate that cross-sectional area by the height and actually get the volume of the shape. So we're going to look at an application of that here. It is a pyramid that we're looking at here as an example. You can do pyramids with just your empirical volume of pyramids formulas, but we're going to do this with integration. So the first thing we need to do is we need to come up with a formula for the cross-sectional area at any point in this pyramid. So let's sort of mark in some sort of cross-sectional location. We'll see there would be some sort of cross-sectional area in there, and this area here is going to be it's going to be a little bit less than 203. In fact, it's going to be a fraction of 203 because this 203 length here starts at 203 there, but it goes to 0 at the end there, and this starts at 190 and goes to 0 there. So those distances are actually going to change depending on how high up and down the pyramid we are. So we might use the height. In fact, we'll use the height from the top. So so we're going to look at x being this height value here, and so what we're going to have is this distance here is actually going to be h out of 153, that's a fraction, times 203. So it's going to be h out of 153 times 203, and this one here is going to be h out of 153 times 190. So if we are 153 meters down, then we've got 153 over 153, we've got all 190. But if we're at 0, we've got 0 153rds, we've got 0 as the distance. So we've actually used that to represent this cross-sectional area. We can then pull that out as a function. So area is going to be, it's always length times width when you're looking at a rectangle in this case. So this area is going to be length times width. It's going to be h over 153 times 203 times h over 153 times 190. And so we can then work on that, and we'll get a h, something like a h squared on 153 squared times 203 times 190, which we can then go and work on with next. So where we're going to go from now is we're going to take this and we're going to now integrate it. We're going to integrate this across the height. So the height always goes from 0 to 153. So the integral we're going to actually perform is the integral from 0 to 153 of the area, so of this function here, so of this h squared times 203 times 190 all over 153 squared, and that's dh with respect to h. So that is actually going to find us the volume, and yes, that just appears on the video. So that's the integral that we're going to do to calculate this volume. So let's step through our integral. This is just a constant. I'm going to leave it as a constant. I'm not even going to do that calculation just yet, because I just want to show you something as we move on. So let's do that integration. So h is the only variable we've got here, so we're just going to integrate with respect to h, increase the power of h by 1, divide by the new power. So we've actually got h cubed on 3 times 203 times 190 all over 153 squared from 0 to 153. So now we substitute in the upper bound minus the lower bound. The lower bound is 0, so 0 times all this is just going to disappear. So we only really need to substitute in the upper bound. So we should get 153 cubed all over 3 times 203 times 190 all over 153 squared. Well, that's cool because we can delete that one and it's going to cancel with 2 of those, and we're almost there. In fact, I look at this, I've got a few tricks happening here, because this 153, that was our height, and 203 by 190, that was my length by width, and we're dividing the whole thing by 3. And I seem to remember that the formula for, it's just dropped off the video there, the formula for, actually let's put it here, divided by 3. Formula for the volume of a pyramid is area base times height times a third. So that's actually what we've done. We've got area of the base times the height times a third to calculate the volume of that pyramid. So it matches up with our empirical formula. Now when you do calculate this, in the end I get something like 1967 070 cubic meters for the volume of that pyramid. So we've just done that using integration as opposed to an empirical formula, but you can see that they do match up, the two methods.